This last video for section 9.2 is going to cover the shapes roses and lemniscates. The difference in the two, they look very similar. I hope you notice that they look very, very similar. But the difference in the two is a rose has to have 3 or more petals. A rose is going to look very flower-like. It's going to have either an even number of petals or an odd number of petals. The even number of petals, it's a little harder to tell the difference between sine and cosine. The odd petals have to be symmetric to the polar axis or the pi/2 axis, depending on whether it's sine or cosine. The lemniscate is a rose with just 2 petals. So we kind of tend to call it a propeller, and you can either have a horizontal propeller or an oblique propeller. We're going to go into the equations of these. They are different. They do not follow any of the other patterns we've had so far. But I did want you to be aware when I'm talking about a rose that I'm talking about these shapes with multiple petals. A lemniscate is just a propeller with 2 petals either horizontally or in an oblique fashion. So the equation for a rose will follow this pattern. It will always be written in the form R equals A times the sine of n theta, where n is an integer, or actually, yes, an n is an integer that is not 0 and is not positive or negative 1. Okay? It can't be 0, it can't be positive or negative 1. So let's talk about why that is. If n was 0, you'd have the sign of no angle at all, and therefore this would not be a rose shape. If you had, it would just be a single number. It'd always be 0 times a, and that would just be a dot. If it was plus or minus 1, if you had a sine of theta, that would go back to a different, it would be very similar to our circles that were offset, only this value wouldn't be a, it would be 2a. So there's a few more restrictions. Whenever n is an even number, you will have 2 times the number of n petals. So if I have an n right here of 4, I would have 2 times 4, or 8 petals. If n is 6, we would have 12 petals. If n is 8, we would have 16 petals. Whenever n is odd, you will have n petals. So if n is an odd number, which cannot be 1, but 3, 5, 7, -1, -3, -5, -7, we will have n petals. And a is the length of the petal. So let me give you an equation. Let's say that I looked at r equals 5 times the sine of 3 theta. I would have to look at, first of all, that n is odd. In this case, n is odd, which means there will be n petals. So this rose would have 3 petals. The a value is 5, which means that each petal will be 5 units long. So how would I graph that? I'm going to go ahead and graph this on, this is just a sketch of the graph. I know that it's sine, which means that it's going to be symmetric based on the pi/2 axis. I know that there will be 3 petals. I know that each petal will be 5 units long. So I could kind of draw myself a little circle at 5. And I know that all 3 of the petals are going to go through the origin at some point. Now, this is a little different because instead of we had positive sign, this is actually positive. It's symmetric here. And so that first petal where the symmetry is going to come in is here. The other 2 petals will go out to the circle, but it will look like this. And if you pick up your graphing calculator and type this in after you've watched the next video, you'll get an idea of how this is going to look. They are all a length of 5. They all have a length of 5, which is the a value, and there are 3 petals to the graph. The next shape, the lemniscate, is a little easier to tell from sine and cosine because the lemniscate is in this form. R squared equals a squared cosine of 2 theta. And it will always be this format. R squared equals a squared cosine of 2 theta, or R squared equals a squared sine of 2 theta. And the difference is that anytime you have cosine, you're going to have your horizontal propeller, and anytime you have sine, you're going to have your oblique propeller. The A is still the length of the propeller, or the pedal, whatever you want to call it. We're going to call it a propeller because that's what the book calls it, a propeller. But this is A squared. So let's take an example. Let's say that I had R squared equals 16 cosine of 2 theta. A squared is 16, so the length of the propeller would be 4. And if I had R squared equals 25 sine of 2 theta, the A squared is 25, and therefore the length of the propeller would be 5. But how am I going to enter this in the calculator? Because you will eventually get to graphing in the calculator. You can enter it as R equals the square root of 16 cosine of 2 theta, or R equals 4 times the square root of cosine of 2 theta. Now let's look at where that came from. We know that the square root of 16 times the cosine of 2 theta is equal to the square root of 16 by itself times the square root of cosine of 2 theta. And the square root of 16 is 4. We don't know the square root of cosine of 2 theta, so we would leave it like that. This problem would be R equals the square root of 25 sine of 2 theta, or R equals 5 times the square root of sine of 2 theta. In this case, this distance right here would be 4 because that's the length of the pedal. In this case, this distance right here would be 5 because that's the length of the propeller. Looking at a couple of example problems for this, let's say that I gave you R equals 6 cosine of 3 theta. Well, I know that this is following the pattern of n theta, and n is 3. N is odd, so this would be a rose, symmetric to the polar axis, 3 petals, and each petal would have a length of 6. All right, the next problem, B, R equals negative 4 sine of 4 theta. Well, this particular problem, n is even. It will be a rose. It will be symmetric to symmetric. I've got sympathetic or something. Symmetric to pi over 2. It will have 8 petals, and each petal will have a length of 4. Now understand that this is negative 4, but remember negative means different in polar graphing. What this is telling me is instead of starting at, for example, pi over 2, we would start at negative 4 from that location, but the petal length would still be 4. The next problem, R squared equals 16 sine of 2 theta. Well, it's an R squared problem, so I know that this is a lemniscate. And I'm going to rewrite it as R equals the square root of 16 sine of 2 theta. R equals 4 square root of sine of 2 theta. So I know that it is going to be an oblique because it's sine. And I know that the length of the petal, right there, the length of the petal will be 4. Last one, R squared equals 36 cosine of 2 theta. Well, I know that this format is R squared, and therefore it is a lemniscate. It's cosine, so it will be a lemniscate that is symmetric to the polar axis and it is horizontal. I'm going to rewrite the problem as the square root of 36 cosine of 2 theta, which is 6 times the square root of cosine of 2 theta. That tells me that this petal right here has a length of 6, and it's going to be, like I said, horizontal. That's all the shapes that we have. The last video that will be up will be how to set your graphing calculator to see the shapes that you want to see and graph it in polar format.